Okay, today we're going to be graphing polynomial functions and answering a whole bunch of questions. So if you look at the instructions on this worksheet, it says, state the maximum number of turns the graph of each function could make. So when you graph polynomials, they could look like this, they could look like that, they could look something like this. And the biggest exponent of the polynomial tells you how many times the polynomial can change direction, meaning how many times it can change from going up to going down. So an x squared polynomial, so x squared plus 2x, say, plus 6, the biggest exponent tells you how many turns are possible. Now, just because there are two possible doesn't mean that there are two, but there can be as many as two. So in this first graph, I'm going up, and then over here I'm going down. So this would be two directions. It could change direction one time. So it could be going up, and then it could be going down. So this is one direction, and then two directions. And notice that this 2 matches that 2. Now that doesn't always happen, but the most of times that it can change is 2. So this one changes directions. We have 1, 2, 3, 4. So I have 2 going down, and I have 2 going up. So this one would have 4 directions. This one here goes up, then it goes down, then it goes up again. So this has 3 directions. So that's what it means by state the maximum number of turns. If I had an x to the 5th, that could have 5 directions. You can have up to 5. That doesn't mean that it has 5. You have to graph it to figure out how many there really are. But it can have up to 5. Okay? Then sketch the graph. That's the next part of the instructions. State the number of real zeros. That means how many times does the graph touch the x-axis. So you might have a graph that never touches, so that would be 0 zeros. You could have a graph that touches twice, so that would have 2 zeros. You could have a graph that touches 5 times, so 1, 2, 3, 4, 5. So you'll state the number of turns, you'll state the number of zeros, and you'll estimate what each of them are. So not only do you want to count how many there are, you want to tell me x equals -8, -5, 0, 3, and 6. And then it also says approximate the relative minima and relative maxima to the nearest tenth. If I had a parabola, this would be called a minimum. If I had a parabola, that went the other direction, this would be called a maximum. Well, maximum means the very highest point. What if the graph has 3 directions? And we look here, that looks like a maximum, but actually there are y values that are higher than that. So it's sort of a maximum. It's a local maximum, or we call it a relative maximum. So I want to know, how high does this little bump reach? So that would be called a relative max. And then down here would be called a relative min. So let's see how we could do this. Let's say that we had the equation y equals x squared minus 4x plus 3. So graph that on your calculator. Go into your y equals. Graph that on your calculator, and we're going to answer all of those questions. So this is an x squared graph. So the maximum number of directions is 2. It can go up and then it can come back down because it's an x squared. So I'm going to go in my calculator. x squared minus 4x, oops, get rid of all that. So x squared minus 4x plus 3. I push graph, and my window is way off. That's not what I want to see, so I'm going to push zoom. I'm going to go down here to number 6 for standard, and it will change my window to the standard window. So the maximum number of directions or turns is 2. Then it also asks you to sketch the graph, so you'd want to draw this graph on your paper. So it looks like this. So there's the sketch. The next question says, state the number of real zeros. So this has 2 real zeros. Real meaning they exist. There are, in fact, ways you can create imaginary zeros. We'll get to that later. Approximate each 0 to the nearest 10th. So this is what we did a couple days ago. Second calc. We go down to number 2. And we do left bound, 0, right bound, 2. My guess will be 1. And the 0 is in fact 1. So there are 2 answers. One of them is 1. And I can do the same thing for the one on the right. So this one looks like it hits at 3. So my left bound will be 2, my right bound will be 4, and my guess will be 3. 2, 4, and 3. And it says x equals 3. So those are my zeros, or my roots. Roots and zeros are the same thing. The next thing says approximate the relative minima and relative maxima to the nearest 10th. So I want to know what is the y value at the bottom of that graph. So I'm going to go into second calc. Number 3 is minimum. And it looks like it happens at x equals 2. So my left bound will be 1, my right bound will be 3, and my guess will be 2. And it says 2 comma negative 1. And the minimum is the bottom of that. So the answer is y equals negative 1. And that's a minimum. What if we had an equation that was a little bit more complicated? So what if we had the equation y equals x to the 4th minus 5x squared minus 3. That's an x to the 4th equation, so it can have 4 directions. So it could look like this. A down, an up, a down, and an up. So the maximum number is 4. That doesn't mean it has 4. It might have 2, but it could have it up to 4. So let's plug that in my calculator. X to the 4th minus 5x squared minus 3. And I push graph. And you notice, in fact, it does look like a W. So sketch the graph. It's the second instruction. So it looks something like this. And it says, state the number of real zeros. Well, how many times does this touch the x-axis? It only touches twice. So there are 2 real zeros. Now I need to find out what those zeros are. So second calc 0. And the first one looks like it's somewhere between negative 3 and negative 2. So my left bound, I'll do negative 3. My right bound, I'll do negative 1. And you can see those arrows. My answer is in that interval. My guess will be negative 2. And the answer is x equals negative 2.35. So that is this root. And do the same thing on the other side. 0, somewhere between 2 and 3. So 2 is my left bound. 3 is my right bound. And then I'll do 2.5 as my guess. And that's going to give me 2.35. So x equals 2.35 on this side. And lastly, I need to calculate the relative mins and maxes. And if you look at this graph, I have one relative max, and I have two relative mins. So to find my relative max, second calc, I'll do maximum. And it looks like it happens at x equals 0. Oh, I must have pushed the wrong button. Number 4. So left bound, -1. Right bound 1. And I'll guess at 0. And I get x equals 0 and y equals -3. So my relative max occurs at is y equals -3. Now in this graph it's kind of nice because my two minimums are actually the same level. So if I find one, I know the other one automatically. So second calc, I want a relative min. It looks like it happens at about 1.5. So left bound 1, right bound 3. My guess will be 2. And I get -9.25. So this is actually not a relative min, it's a absolute min. So the minimum is y equals -9.25. And that's how far down this reaches. And it just so happens that the other one is also -9.25. Okay, so you have, it looks like 8 polynomials to graph, and you need to answer all of those questions for each polynomial. Good luck.